So today let me introduce the propositional logic in the discrete mathematics. First, we have to ask a question. What is proposition? You can say statement. Statement is a declarative sentence that can be either true or false. For instance, today is Monday. We can say it is propositions because today can either be Monday or other weekdays. So we can identify the true or false. So let's come to a non-example. Please close the door. It is not a proposition since it doesn't have truth value. It's just an action. Okay, so let's move to another thing is called truth table. What is a truth table? It's a tool that shows the results of logical operators on propositions. It can be either true or false. So why we have to use truth table? Since it's a tool that helps us to evaluate the complex reasoning by showing how operators affect propositions. So let's take a short look about the truth table. So there you will see the 5 logical operators, and we also introduce another logical operator. So today we will learn 6 logical operators. So let's move to the first logical operators, negation. Negation is an array operator. It will transform proposition into the negative statement. For instance, if P equals I have a brown hair, then negation P equals to I don't have a brown hair. So let's take a short look about truth table. If P is true, then negation P will equal F. If P is false, the negation P will equals to true. Let's introduce the second operator, conjunction. Conjunction is the binary operator, which means it must need 2 statements to use. So there's an example about the use of conjunction. If P equals to I will have salad for lunch, and Q equals to I will have a steak for dinner, then P conjunct Q will equals to I will have salad for lunch and steak for dinner. So you can see it is conjunction of 2 propositions. So let's take a look about truth table. If both Q and P are true, their conjunction will be true. But if one of the conjunction is not true, if one of the proposition not true, the P conjunct Q will be false. So finally, let's move to the third operator, disjunction. Disjunction is also the binary operator. Let's take a look about the example. P equals to my car has a bad engine, and Q equals to my car has a bad carburetor. Then P disjunct Q will equals to either my car has a bad engine or a bad carburetor. So take a look about choose table. We will understand it more. If P and Q are both trues, their disjunction will be trues. And if P or Q, one of them is true and the other is false, their disjunction will still be true. And if their statements are both false, the disjunction will be false. So you can see if one of the statements are true, the disjunction will be always true. So there's a summary about what we learned about disjunction and conjunction. Okay, so there's a phrase summary. We learned that if we have n propositions conjunctions, we will have to need two power of n rows to write down because we have to compare its difference. So there's comes a simple exercise. If there are 10 propositions, how many rows we need? I will give you a 10 seconds to think. Alright. The answer is 2 power of 10. It will equal to 1024 rows we need. Okay. So there's another things that you have to know about those three logical operators. The operators can consist the base of every logic representation, which means you can use negation, disjunction, conjunction to consist the every logic representation. But actually, in reality, we use and net is not plus and nor is not plus or to consist of base. But it's actually still a basic